Today in this video we're going to see about the 21st module of the ISS, the Harmony Node 2. Let's start the video. The Harmony module of the International Space Station ISS serves as a critical hub for connecting various modules. Much like the central fuselage of a high-performance aircraft that integrates wings, engines, and control surfaces. Each attachment point within the Harmony module functions similarly to the wing to fuselage junction of an aircraft. Precise engineering ensures optimal load distribution and structural integrity. Harmony's design incorporates robust materials and connections to maintain stability and functionality, facilitating seamless operations and life-supporting systems across the ISS in space. The Harmony module, also known as Node 2, was manufactured by 3D Salinia Space at its facility in Turin, Italy. Though manufactured by a European company, it is considered an American module as it was manufactured under the contract of NASA. The Italian space agency ASA formally handed over Harmony to ESA, which then transferred ownership to NASA on June 18, 2003. This transfer took place in the Space Station Processing Facility SSPF at Kennedy Space Center, marking a crucial step in the barrier agreement signed between ESA and NASA in Turin on October 8, 1997. Harmony was delivered at Kennedy Space Center in Florida on June 1, 2003 after being transported in an Airbus Beluga, an oversized cargo aircraft. Once it arrived, the module underwent a thorough post-transportation inspection. The Harmony was made from a combination of advanced materials and engineering techniques designed to ensure its functionality and durability in the harsh environment of space. Its primary structure consists of cylindrical pressure shells crafted from 2219 T851 aluminum alloys, known for its exceptional strength and resistance to stress corrosion. This robust shell, measuring 5.1 cm 2-inch thick, is complemented by two end cones that enhance its structural integrity to provide thermal insulation. Harmony is enveloped in a gold-diced Kapton blanket, which effectively reflects solar radiation while maintaining optimal internal temperatures. Beneath these panels, a secondary layer of Kevlar or resin provides additional protection, leveraging Kevlar's lightweight yet high-strength properties to further mitigate impact risks. The design of Harmony draws inspiration from the existing multi-purpose logistics module Raffaello and the European Space Agency's Columbus module. The Harmony module was launched as part of the Assembly Mission 10A aboard the Space Shuttle Discovery STS-120 on October 23, 2007, marking a significant milestone in the ongoing construction of the International Space Station ISS. This mission was originally planned to launch after 9A but was postponed to ensure the ISS's thrust system remained symmetrical and fully integrated. As Discovery moved to Vehicle Assembly Building VAB on September 19, 2007 after resolving a hydraulic fluid leak in the right main landing gear strut. It was mated with the external tank and solid rocket boosters. The shuttle arrived at Launch Complex 39A on September 30, 2007, where the STS-120 group began final preparations, including a terminal countdown demonstration test known as the dress rehearsal. On launch day, Discovery lifted off on time at 11:38 EDT. Despite a brief concern over a small piece of ice found on the hydrogen umbilical, NASA flight controllers determined that the ice was too small to threaten the shuttle's thermal protection system (TPS). With favorable weather conditions, the launch went ahead as planned. And although some minor debris events were observed during ascent, they were deemed not alarming. The successful launch of STS-120 was a crucial step in enhancing the ISS, facilitating ongoing research and fostering international collaboration in space. reaching orbit, the crew of STS-120 aboard the shuttle Discovery began their meticulous preparations for docking. The mission commenced on October 24, 2007, with the crew dedicating their first full day in space to various tasks, including the RCC Reinforced Carbon-to-Carbon Survey and the inspection of the shuttle systems. The Shuttle Remote Manipulation System Canada and the Orbiter Boom Sensor System OBSS were employed to gather crucial data regarding the vehicle's integrity. On October 25, as Discovery approached the ISS, the crew executed the rendezvous procedures, culminating in a pivotal rendezvous pitch maneuver (RPM). This 1 degree per second pitch maneuver was critical, allowing the crew on the station to photograph the TPS of the shuttle. At 12:40 UTC, successful docking was achieved, and the hatches between the shuttle and the ISS were opened. The Expedition 16 crew welcomed the STS-120 commander Melroy and her team, marking a collaborative effort in space exploration. The next significant phase occurred on October 26 when the team prepared for the first EVA of the mission. The EVA began at 10:02 UTC, with astronauts Parazinski and Wheelock successfully completing all activities. Which included preparing Harmony for removal from the shuttle's payload bay. The crew aboard the station operated the robotic arm to maneuver the Harmony into position on the Unity Node 1's port side CBM port. By 15:38 UTC, the Harmony was officially mated to the ISS, expanding the station's living volume by nearly 20%. This addition was crucial for future crewed missions, as it provided necessary space for additional science modules and increased life support capabilities. The integration of Harmony into the ISS represents not only a technical achievement, but also a step forward in humanity's quest for sustained presence in low Earth orbit. As the hatch to Harmony was opened at 12:24 UTC, the first astronauts entered, wearing masks to ensure safety while the air duct was installed to circulate air through the node. Inside Harmony, the crew had the task of removing approximately 700 screws and bolts, securing equipment and panels for launch safety. As the mission progressed, the importance of collaboration continued to be evident during the second EVA on October 28. Parazinski and Tani commenced their spacewalk at 9:32 UTC, beginning with the removal of attachments to the Z1. This critical task allowed the P6 truss to be maneuvered into its new location on the outboard end of the P5 truss spacer. The work completed during the EVA not only demonstrated the astronauts' technical skills, but also highlighted the operational complexity of moving large structures in space. While installing handrails on Harmony and inspecting components for potential issues, Tani discovered metal shavings on the solar alpha rotary joint SARJ. This discovery prompted additional inspections and alternations to future mission plans, showcasing the adaptability required in space missions to address unforeseen challenges. The integration of the P6 truss into the ISS was planned for the following days, with discussions ongoing about the SARJ and ensuring optimal performance for the station's solar arrays. October 30 marked the third EVA, which concluded with successful installation of the P6 solar arrays onto the P5 truss. During the deployment of the arrays, however, a tear was identified in the 4B solar arrays, prompting immediate concern from the mission managers. This incident required the crew to halt operations and analyze the situation carefully. This incident highlighted the need for ongoing vigilance and rapid response protocols in the face of technical anomalies in the dynamic environment of space. The creation of a cuff-link apparatus was a key innovation designed to alleviate stress on the damaged solar array hinges, exemplifying the engineering ingenuity fostered by the challenges of operations in microgravity environment. After the solar arrays on the P6 were repaired using the cuff-link apparatus, they were successfully deployed. Following days of preparing the interior of Harmony module, the STS-120 crew undocked from the ISS on November 5, 2007, flight day 14, and proceeded to depart from the station. They conducted a customary fly-around of the ISS. Before on flight day 16, November 7th, performing the deorbit burn at 16:59 UTC to lower the shuttle's orbit. Later, they successfully landed at Kennedy Space Center at 13:01 EST. After 8 days, on November 14, 2007, the ISS crew, using the Canadarm2 and connecting 3 EVS for assistance, relocated PMA-2 from Destiny's forward port and berthed it to Harmony's forward CBM. The crew then relocated the Harmony from its temporary storage location on Unity's port side and installed it to Destiny's forward port, where it was permanently positioned. This was the first large operation using the Canadarm2 without a shuttle present. In conclusion, the Harmony Module Node 2 is a pivotal component of the International Space Station, facilitating international collaboration and scientific research. With its 6 common berthing mechanisms (CBMs), Harmony effectively connects various modules and spacecrafts, enhancing the station's capabilities. I hope this video on the Harmony module was interesting and informative. We'll meet you in the next video with another interesting module. Take care. Bye.